Hello, and welcome to Equations of Lines Part 2 for college algebra. We're going to look at linear regression and data analysis. So we're going to use the calculator to do this rather than doing it by hand. When I was a student, we had to do all linear regressions by hand, and I could tell you, I prefer to use calculator, and so I prefer to teach it that way too. We're a technological society. We need to embrace that. All right, so let's start with some definitions. When information is given about a model, there's generally only a certain amount of data under consideration, right? We don't have data points for every single year or every single month or every single day or every single person. Interpolation occurs, and it sounded like I said that wrong, but I didn't. Interpolation occurs when we estimate the values between given data points. Extrapolation occurs when we estimate for values that are not between the given data points. In general, interpolation is more accurate than extrapolation. Okay, so it's extra, it's outside, inter, it's inside. All right, so this example, this table lists the number of bankruptcies filed in thousands for selected years. We want to make a scatter plot of the data, so we're going to use our graphing calculator friend over here. And to make a scatter plot, the first thing I'm going to do is go to Stat, and I'm going to edit my list, so I'm going to use number 1 there. I'm going to put my years in list 1, 2006, 2007, 2008, 2009, and 2010. I don't know why we don't call it 2009, but it's weird. In list 2, I'm going to put the corresponding y values, 160, 220, 290, 380, and 425. Now before I quit from this page, this screen on my calculator, I want to make sure 2006, 7, 8, 9, and 10. Good. Now my y values, 160, 220, 290, 380, 425. You could save yourself a lot of future problems. Future you will thank you for this. If you just check these right away after you enter them, then we know that our data is going to be okay. So I'm going to quit out of here. So I use second. Since quit is in blue, I use the blue button first. And I'm going to go to stat plot. So again, it's in blue. I'll use the blue button to access stat plot. Plots on. So I'm going to hit enter for it to toggle on. This is a scatter plot. List 1, list 2, fantastic. Let's set up our window. Will an x value of negative 10 to 10 be appropriate? I would say no. I'm going to start with an x value of 2000. I'm going to silence my phone since it seems to like to ding ding when I am recording. I'm a big fan of the Roadrunner. It was the Roadrunner beep beep. Case you heard it. If you didn't, I have no idea what you're talking about. The x maximum, let me see. I went from 2000, so I went 4 years one side. I don't know. Maybe let's go 2015. 2015. And scale, yeah, we could go a scale of 1. That'll be fine. Our y values. We're looking at bankruptcies, and I'm going to start at 0 just because I have hopes for everyone being able to buy their home. Looks like the biggest value is 425, so I'm going to go a little above that. I guess more than a little. Maybe I'll take it back. Let's go with 500. And my y scale is generally about a tenth. I know there's a distance of 15 here, and 1 is not a tenth, but it's close enough. It's good enough. Now I can graph this, and I see that my stat plots, my little data points here, they're not in a straight line, but they're fairly close. And this fairly close is sometimes good enough. And we can even put this scatter plot. Oh, you don't need to see that. Trust me. Yep, I'm doing this right in the recording because I don't want to have to save the screenshot any other way. All right, so let's paste this in here. There's our little scatter plot. All right, there we go. I do not have any data on the axes on here, but we found a scatter plot. That's what mine looks like. Find a formula in point slope form for a linear function that models the data. Point slope form, huh? Ooh, I don't want to. And I don't want to enough that I'm not going to. What I'm going to do instead is I'm going to go to Stat, my calculator. I'm going to go over to Calculate, and I'm going to ask it to calculate a linear regression. Linear regression, the X list is list 1. The Y list is stored in list 2. There are no frequencies. These are useful when we have like list 3 would sometimes say, all right, we have 3 of this data point and 5 of this and 7. We don't need that here. But I will store my regression equation. I'm going to try to speak as slowly as possible. Don't forget, you can rewind. I want to store my regression equation in Y1. So I'm going to click Variables. I'll arrow over to Y variables, select a function, and choose Y1. So now after it creates this linear regression, it's going to store it in Y1. Now I'm going to arrow down and tell it to calculate. Now this is a fairly good regression. It gives us our slope of 69 and our y-intercept of negative 138,257. But there's some information missing here. So what we can do is we can go to the catalog, and the catalog is right here, second function of 0. And I want correlation coefficient. See this A? I could hit program and it'll drop me down to the C's. That's not what I want though. I actually want diagnostic. I want to go to D. I'm going to turn my diagnostic on. Diagnostic on. So now when I repeat, second function enter will bring up your previous commands. Now we have this r squared, which is correlation coefficient. R squared, the closer it is to 1, the better fit our data is going to be towards this line given to us. The r is the square root of r squared, and if it's positive, it tells us our data is increasing. If r is negative, it'll tell us our data is decreasing and how closely it is doing so, and so forth. So the correlation coefficients, very, very helpful. Let's see if I could find out where I put down my fancy pen. There we go. Let's use a marker. Come on. There we go. I didn't use point slope form. I encourage you to not do that either. You could pick 2 data points that you think are the best. Maybe, let me see a line through here. Maybe I would choose this data point and this data point, and I could find a regression model just using 2 points and find the slope and the y and doing all that. But this one is going to be way closer than we could ever get using these 2 values. Let's just do it. The slope is 380 minus 160 divided by 2009 minus 2006. 380 minus 160 is 220 divided by 3. Of course I did that. 3 years different. That's frustrating. 220, I want to save this screen though, so let's just make a little cut of this screen while we're at it. I'll just put that in the back and wait until I need it again. 220. 220 divided by 373. So we can see that the slope is not exactly the same, but since this is a real life problem, I am going to do approximately 73.3. Real life problems, we generally round. Let me see, what else can we do? Now we find y minus 380 equals 73.3 times x minus 2009. I don't know why I didn't use the first one, but this is the point slope form of the equation of the line, and we can check after we multiply it all out and add it together. It'll be fairly close to our linear regression formula. If we graph the data and the equation in the same window, remember, we stored the equation in Y1. We have our plot on. That is a much better line than the line I drew, right? But it's there. So let me do a couple things here. Let me make sure I'm doing the right thing. I am not doing the right thing. All right. Sometimes I just have to get out of my own way. You ever have that issue? Sometimes you're the reason you can't do something, and it's kind of frustrating. Interpret the slope of the graph. So if we're looking at this particular graph, graph the data in the same plane. Sorry. Yeah, I'm just confusing myself. I'm all about the one take though, so I'll be showing you exactly what it is that I would do in a regular class. Fumble around with this stuff sometimes too in regular class. Technology's no different. All right. At least here I'm not struggling with markers. Interpret the slope. So what is this? This is the number of bankruptcies per year. So the bankruptcies were increasing by about 69,000 per year. And I used the 69 because I know that that's the most accurate one. I could have used 73.3 if I was using a point slope form and picking two data points, which is just bad math. Don't do that. Remember, bankruptcies are in thousands. So this is not 160 bankruptcies. If you know anything about the housing collapse in the United States of 2008, you understand why these bankruptcies were so large. They jumped. So it was definitely not just 380 people lost their house. It was 380,000 in 2009. So that's going to give us our units. Estimate the number of bankruptcies in 2014. Well, to estimate that, I'm going to go back to my calculator, and I'm going to click Trace. And when I click Trace, this is on my plot. If I arrow down, now it's on my line. So now that I'm on my line, I can put in 2014. And it gives me a Y value of 709. 709,000. Either way you want to write it, bankruptcies in 2014. This is extrapolation because it's extra, it's outside of the given window of data sets. Right? The data goes up to 2010. 2014 is past that, is outside the data set, so it's extrapolation. All right, so let's see what I can do here. Let's bring this cursor up. I want to keep this all on a page if I can. The percentage of smartphone revenues that were due to iPhones is shown in the table. All right, so use the 4 oldest data points to find a linear function that models these data. So we're going to go back to stat, and we're going to edit our lists. I encourage you not to use delete. Delete just makes one item go away, but if used clear, it'll clear the whole list. I'm going to show you what delete does. If you're at the top of the list and you hit delete, all it did was take out my list number. To get that back, do second, insert the INS. Down here is list 3. Let's not call it theta. Let's use blue, call it list 3. And now your list 3 is back. So please do not use delete. If you want to clear an entire row, wow, I can't speak. Clear it, but don't delete the list. All right, clear it. So now I'm just going to use the first four: 2008, 2009, 2010, and 2011. The Y values, the percentage of smartphone revenues due to iPhones: 3% in 2008, 10% in 2009, 16%. They're finally knocking Nokia down a little bit. I bet if you have a Nokia, it still works though. Find a linear function. Fantastic. Now that we're finished with our data, we kind of checked, made sure along the way that it was going well. Clear that out. Go back to stat. Calculate a linear regression. And again, I'm going to store this in variables, y variables, function y1. So it'll overwrite what was already there. Notice since I turned my diagnostic on, it's now on all the time. Interesting how our slopes are pretty closely related in these examples. Let's write this one in blue. Y equals 6.9x minus 13852.3. 13,852.3. Let's make this a function, right? It wants a function f, so let's call it what it is. This is f of x. Does f model these data exactly or approximately? Now, according to our correlation coefficient, it's going to be pretty close to exact. Let's take a look at the window setup first. 2000 to 2015. Maybe I'll bring this up a little bit to 2005 and bring this up to 2020. I can still go by one there. My Y values, we're looking at percentages, so there's no sense in going past 100. Let's take a look at this graph. I would say nearly perfect. Nearly perfect. All right, so it's really close, and that correlation coefficient of 0.997 also tells us that they are nearly perfect. Use f to estimate this percentage in 2007. Use the function, so 6.9 times 2007 minus 13,852.3. I'm going to, again, evaluate this using my calculator. That's not the button I wanted. I'm going to trace. I'm going to arrow down so I'm on Y1, and I'm going to enter the data value 2007, and it tells me that my Y value is -4. That's weird. So this is extrapolation because it's extra, right? It's outside of the data values. So this says revenues due to iPhones were at -4%. This is what's called a model breakdown. You know why that's a model breakdown? Because iPhones were not released in 2007. The first iPhone was in 2008. That's crazy. How many different versions have they had in the last 12 years? Holy smokes. Okay, so it doesn't always make sense in real world when we do extrapolation, and that's why interpolation is almost always more exact. If I wanted to estimate this percentage in 2015, I'm going to go back to my window. I'm still in trace, I believe. I'm going to put in 2015, back to my graphs, back to trace, down to the Y graph, 51.2. Using f of x, we would find that in 2015, there should have been 51.2% of the smartphone revenues due to iPhones. And we can see that that's not true. I believe iPhones had a huge issue in somewhere around this time, and they were not selling quite as well. All right, this is already longer than I expected it to. But given this data set, we can find the linear regression. I am going to bring this back down here. Do a little work while we are finding linear regressions. Let's go back to stat. And we're going to edit. Let's clear our list 2. Let's clear our list 1. And we'll put in our x values in list 1. -2, a 1, and a 3. We will then put in our y values, 2, 0, -2 that corresponds. We can see our points here, -2, 2, 1, 0, 3, -2. Fantastic. Lists are the same length. I'm going to quit from here and go back to stat and calculate a linear regression. And I don't need to store it at all this time. We're not going to graph it. We just want to look at this window and take it back to put it in here. Let's make that smaller, get it all on that one page there. There we go. All right, so the linear regression using technology, I find my A coefficient, my slope, to be a -0.789. My y-intercept to be a 0.526. Correlation coefficient 0.986. So it's not exactly like on the lines. But if we look at the stat plots, plots on, let's set our window appropriately. Let's zoom back to a decimal window. We can see that, yeah, they're not on a straight line. Even if we put it on a zoom standard window, -10 to 10, they still don't look like they're on a straight line. But we do see with this negative R value, we do see that it is a negative slope. So it tells us that the data set is going down. All right, this was supposed to be like a 5 or 10 minute video. Here it is 22 minutes later. I do appreciate you listening. Maybe think about subscribing if you're not watching these embedded in our learning management system. All right, thanks.